Hi, so today we're going to talk about how to simplify it's called rationalizing complex numbers. And what you're going to do is you're going to try and get rid of all the i's in the denominator. So what you do is you force your denominator to have what's called a difference of squares, and that will it'll simplify and get rid of all your get rid of all your i's. I'm sorry. And so the way you do that is you'll notice the numbers in here are the same, but that the sign in the middle is different. And that's what makes it a complex conjugate. It's just the same numbers with a different sign in the middle. And so then what you do is you put one above the other, and then you just multiply twice. And so what I'm going to do is I'm going to distribute. I'm going to erase this so I can distribute. And I'm going to multiply 1 times 1, and that'll get me 1. And I'm going to multiply 1 times negative 2i, and I'll get negative 2i. I'm going to multiply by 2i times 1, and that'll get me positive 2i. And then positive times negative is negative. 2 times 2 is 4, and I times I is I squared. So what we're going to do now is simplify this. You'll notice we can get rid of some like terms here in the center because they're the opposite of each other. And you might remember from the lecture the other day, I squared is the equivalent of negative 1. So we're going to go 1 minus 4 times negative 1. And then when you're going to do your multiplication first, so it'll become 1 plus 4. And so your denominator is going to become 5, which is why you multiplied by the complex conjugate in the first place. And so then what we're going to do is do the numerator now. So that gets you a denominator. I'm going to move this guy out of the way. So that gets you the denominator of 5. And now I'm going to work up because that's the direction this works. And I'm going to distribute 8 times 1 and 8 times negative 2i. And that's going to get me 8 minus 16i. And so when you do that, you're just going to move that over here, 8 minus 16i. And so that is a right answer. This would be right. But this is written as a complex number in standard form. Remember, that is a real part, plus bi, the complex part. And so what we're going to do is distribute the 5 from the denominator to each of these terms separately. So you'll see it's 8 over 5 minus 16 over 5 times I. And so that is the rightest of the answers, and we're going to do it that way. So let's try another one. So when we come over here, once again, we're going to write the complex conjugate. And so you'll notice the numbers are 1 and I, but the sign in between this time is negative, and we're going to make it positive. And then we're going to put 1 in the numerator too. And that way you're really just creating an equivalent fraction because you're multiplying the top and the bottom by the same thing. I like parentheses. They make my life easier. So I'm going to go 1 times 1 again, which is 1. 1 times I, which is I. I'm going to go negative I times 1 is negative I. And I'm going to go negative times positive is negative, and I times I is I squared. And so what's going to happen then when I go in and combine like terms, my I and minus I will cancel each other out, and I'll get 1. This I squared becomes negative 1, so it becomes 1 minus 1, which is 1 minus negative 1, which is just 2. And so your denominator in this one has become 2. And now we're going to do that distribution part in the numerator again. We're going to go 2 times 1 is 2. 2 times I is 2i. I times 1 is I. and then I times I is I squared. And it's positive. And so now we're going to combine like terms. At this point, it might be easiest to make your -1, or substitute in the -1, I squared equals -1. Might be easiest to substitute in there. So we're going to go, all right, so this, we know, oops, sorry, erased everything. This becomes -1. And now when I combine like terms, I'll just get 2 plus -1 is 1. 2i plus I is 3i. So my denominator, or my numerator, I'm sorry, will become 1 plus 3i. I would mark this right now in this one, but if I asked for it in standard form, the right answer would be 1/2 plus 3/2 I, because you're allowed to distribute a denominator the same way you can a numerator. And so that's how you simplify those complex numbers. And so the next part would be, so what happens if I have just an I down there? And so we know the way to turn that into a number so that you don't have an I anymore is just to multiply the top and bottom by I, because that's going to get you I squared in the denominator. And we know that I squared becomes -1. And therefore, we no longer have a negative, or we no longer have an I in the denominator. So now we're going to distribute. It's going to become 2I plus 3I squared. But remember, 3I is negative, 3I squared is -1. So if you think about what standard form is this time, this is going to turn out to be -3 plus 2i, and that's going to be your numerator here. If you distribute this, -3 over -1 plus 2 over -1i, this becomes +3 minus 2i. And so there's your simplified version of that. Okay, and so the reason that we've bothered to learn all this is so that we can find imaginary solutions for quadratic equations. And so that's kind of what this part is for. So here's one of those equations. I'm going to copy it and move it down lower in my notes. And so what we're going to do is we are going to, oops, sorry, I moved it. We are going to put it so that it's in standard form and set equal to 0. And so if you notice, there's no x term in this. And so I'm going to fill in that space with 0x. And I'm going to end up with ax squared plus bx plus c. So sometimes a's are missing and sometimes b's are missing. And whenever that's true, I put a 0 in its place to help me remember that when I use the quadratic formula. So the next part I'm going to use is to find the discriminant, which is b squared minus 4ac. And so b squared minus 4ac, in this case, b is 0. So we're going to go 0 squared minus 4 times 3 times 72. And so that's going to get us negative, I believe it's 864. And you might recall when you have a negative discriminant, you have two imaginary solutions. And when you have a positive discriminant, you have two real solutions. And when you have it equal to 0, it's just one real solution. And so what we're going to do is say, oh, well, in this case, we're going to have two imaginary solutions. And to find them, we're going to substitute into the quadratic formula. X is equal to negative b plus or minus the square root of the discriminant all over 2 times the a value. So we're going to go the opposite of b plus or minus the square root of negative 864, all divided by 2 times 6. And so when you have that, this would be all right with me right now. This is kind of our new stuff. This would be okay with me, but there's a writer version of it. And so what we're going to do is we got to do one more thing for sure in order to get credit. It would be 0, but we don't need that. We got to remember that this can split into -1 and positive 864, and that we know the square root of -1 is I. The square root of 864. I'm sorry, I did the math here already. This should be a 3. This part right here. Should have been a 3. And then the denominator would be 6. So if you got to this point, I'd be really happy. But we could take it farther. On Wednesday, we were working on simplifying rational numbers. And so, for example, when I look at 864, I know a 4 can come out of it. And so if I do that, I'm going to get 4 and 216. Well, I know, so that's 1. I know 216 can break down farther, and it's a perfect square of 36 times a not perfect square of 6. So I'm going to rewrite my 864. I'm going to leave my I, and then multiply it by the square root of 4, the square root of 36, and the square root of 6. And my denominator stays. I'm going to keep simplifying, just like we did on the delta math, and it's going to become 2 times 6 times the square root of 6. And so if you notice, I could simplify this way. You would probably write your answer 2I root 6 because you don't want to accidentally make it look like the I is in the radical. And it's still plus or minus. So you have 2 imaginary solutions, and their values are plus or minus 2I root 6. So that means it's 2I root 6 and negative 2I root 6. If you want to, that's a positive. So that would be the way you could do that. And so that's how you would do it. So what did we do? We went in and wrote it in standard form, and we made sure it was equal to 0. We then did the discriminant. Once you've done the discriminant, you simplify it so that you get out the imaginary part. You want that I in your solution if your discriminant is negative. And then you start to simplify it. So either one of these is technically the right answer. This one is the best answer because it is a simplified radical. Right now, because we're learning, I'd be okay with you having the first one, but if you were taking a multiple choice test, you would want to have the second one. And so I hope that helps. Let me know. I'll be in my office hours from 9 to 2 on Monday and Tuesday of next week. So if you need any help, please come see me. Thanks. Bye.